Welcome to this tutorial for MCP Mod and nQuery. In this tutorial, we will show how to do a sample size calculation when designing an MCP Mod study for Phase 2 clinical trials by looking at an example of a Phase 2 trial for a treatment for generalized anxiety disorder. MCP Mod is an innovative approach for Phase 2 clinical trials, which uses a unified framework and statistical methodology to combine into a single trial the Phase 2A and Phase 2B approaches used traditionally. In a traditional clinical trial, the Phase 2A trial is one which is trying to establish proof of concept or POC and simply evaluates if one or more of the doses that may be considered has any efficacy over placebo. If proof of concept is found in the Phase 2A trial, the traditional trial would proceed to the Phase 2B stage, where a dose-finding study would occur which looks to find the dose or doses of the proposed treatment which have the highest beneficial effect and which are then brought onto the Phase 3 clinical trial. The MCP Mod procedure combines the statistical analysis from Phase 2A and Phase 2B into a single clinical trial. To do this, the MCP Mod approach proposes that you select, before you do any modelling or analysis, the proposed models that you believe could characterise your dose-response curve. Once you've done that and selected your other required inputs, such as your test significance level, you can proceed into the MCP Mod procedure. In this procedure, we first use a multiple comparison procedure, or MCP, to establish if any of the dose levels are statistically significant above placebo in a robust way. If the MCP analysis finds that there is a statistically significant difference using the proposed set of models, then we proceed to the modelling stage, at which point the model or models which perform best at the MCP stage are selected and used to evaluate which dose or doses are most appropriate for continuation to Phase 3 based on their efficacy. By using a unified framework, we can reduce the cost of Phase 2 trials by combining two separate trials into a single trial, while also ensuring robust type 1 error control by ensuring the statistical methods used at Phase 2A stage are also being continued on to our decisions in the Phase 2B stage, or from proof of concept to dose finding. In nQuery, to use MCP Mod for sample size, we need to do three things. Firstly, we need to give our overall study parameters, such as the significance level and the expected response at placebo and the maximum expected response. In this study, they had a 0.05 at the one-sided level significance test, and they wanted to evaluate 6 doses and 6 models, with the 6 doses including the placebo dose, where there will be 0 dose of the proposed treatment. In MCP Mod, because we're evaluating multiple models for their power, you have a choice for how you want to define the overall power for the MCP Mod procedure. The default is to use the mean power across all of the proposed models. However, we can also look at the minimum, maximum, or median power across the 6. In this study, they defined the effect sizes in terms of change from placebo, and thus the effect under the placebo dose would be equal to 0. They also used a standardized effect size, which in effect means on the standard normal scale, which has a variance of 1. This means that the maximum treatment effect is equal to 0.4 on the standardized scale, and the standard deviation is set to 1. They also had a target power of 80%. As this procedure relies on a complex approach to the multivariate t distribution, simulation is used for the multivariate t distribution statistics. You can also set the random seed if you want to replicate your result fully later on, exactly. Once we've completed the overall study parameter, we now need to go on to the second part, which is contained in the side table, which will appear automatically below the main table once you specify the number of doses and the number of models. This table on the left-hand side contains the doses that will be considered in this study. Remember, this is the actual dose that you will receive of a particular drug whether that be in volumetric terms or in terms of weight terms, such as milliliters or grams respectively. In this case, the doses were in terms of milligrams, and the dose levels were equal to 10, 25, 50, 100, and 150 milligrams. The weighting row here can allow us to give unequal sample sizes per dose level if we require, with the default being equal per group, with these weightings equal to 1. The sample size column here will be filled in after the sample size calculation is complete. The final part we need to do is to enter the models that will be considered in this MCP Mod procedure. As stated before, in the MCP Mod approach, we select, before the study occurs, a selection of different models which we think might accurately reflect the dose-response curve, and then evaluate our MCP Mod procedure based on all of those potential models, and then select the model that performs best on the actual data. In this case, 6 models were considered, the first of which was the simple linear model, where we expect that for each unit of dose increase, we would expect a constant increase in the dose response. This requires no additional parameter input. Next is the Emax model, where we need to specify the ED50, which is the dose at which we'd expect 50% of the maximum effect, in this case equal to 0.4. And that could vary significantly depending on your characterization, but in this case, they expected 50% of the maximum effect to occur at a dose level of 25 under this particular Emax model. Note that we could specify multiple models of the same type if we use different parameters for those models that require an additional parameter or parameters. Next, we have the logistic model, which is very related to the Emax model, except the Emax model is effectively the logistic model, but on the log-scaled data. In this case, they assume that the ED50 would occur at 50 milligrams with a second parameter of 10.881. This effectively defines the slope, or how quickly you go from the minimum effect or placebo effect to the maximum effect. We then had an exponential model with a mean change of 85. And then 2 beta models. So most of the models included in nQuery, besides the beta and quadratic, are what would be considered monotonically increasing models. In other words, they assume that the effect always increases with dose. However, the beta model and quadratic are both flexible models, which allow you to specify dose-response curves where decreases can occur for higher dose levels within the range considered. That can be done flexibly using the 2 shape parameters of the beta distribution. In this case, the first model has a parameter of 0.33 and a B parameter of 2.31. This would give a monotonically increasing curve, similar to our other models. The scaling parameter, or parameter 3, is set to 200 and simply scales the beta distribution from being 0 to 1 to being 0 to this parameter. We want to ensure that that scaling includes the entirety of the dose range specified over here, and thus is set to 200 in this case. The second beta parameter is equal to 1.39, and 1.39 for our 2 shape parameters, and this is also scaled to 200. The maximum likelihood estimator of the beta distribution, assuming both are over 1, is approximately equal to A divided by A plus B, and thus we would expect this to give a range of around 50% 200, or in other words, around 100. Now we've filled in this table fully, we will have a sample size calculation. You will note that in the rest of the side table, there are additional rows for the other parameters that are either inputs or outputs to the particular per model basis. So we can see that for each model, the placebo dose is set to 0 by default, and the maximum effective dose is set to 150, or the maximum dose by default. However, we'll see in a moment that for models that aren't monotonically increasing, these can actually vary from that original estimate. The E0 and Emax are simply the effect that we expect at placebo and the effect that we expect at the maximum outside of the range considered here. In other words, for one that increases until it reaches an asymptote, it will give the asymptotic effect size in the Emax row. If you want more detail on the particular models provided, these are available from the help cards, which are automatically displayed when you select the model, parameter 1, parameter 2, and parameter 3 rows. Once the MCP Mod sample size is calculated, the overall sample size is given here, and the sample size per group of 62 at each dose level is given here. You can also see that the critical t statistic for the multivariate t distribution is given by this calculation as well. You can see that the mean or average power is equal to 80%, but on a per model basis, we can see that the linear model had a power of around 78.8%, the Emax around 77.1%, the logistic had about 91.5% power, 76.14% for the exponential, 82.4% for the beta model, which had monotonic increasing, and only 76% for the model that peaked around 100. We can actually see the dose response curves by selecting the Plot Dose Responses button at the top of the MCP Mod side table. And you can see here the linear, Emax, logistic, exponential, beta models, and you can see the expected doses under each of these models. To learn more, visit statsolves.com. Thank you for watching.